Hello dear students, in this video I'll continue with the 5th unit Inferential Statistics. In this video, we'll see the problems from exercise 5.1 of CBSE Handbook. The first problem is identify the below statement as biased or unbiased statement. Justify your answer. For a survey about daily mobile uses by students, random selection of 20 students from a school. So here we have to identify the statement as a biased or an unbiased statement. Here a sample of 20 students, they are selected at random. So it is an unbiased statement. It is an unbiased statement as there is random sampling. If we have random sampling, then each student in the population has an equal chance of being selected in the sample. So it is an unbiased statement. Moving on to the next question. Find the critical t-value for alpha equal to 0.1 with 22 degrees of freedom for a left-tailed test. Then find the critical t-values for alpha equal to 0.1 with degrees of freedom 18 for a two-tailed t-test. So here this is very easy. If we see the t-distribution table, they have already given area in one tail and area in two tails for different degrees of freedom. So for the first subdivision, we have to find the critical t-value for alpha equal to 0.01 for a left tail test. If it is a left tail test, it means area is in one tail. So we have to see for 0.01 and degrees of freedom, which is 22. The value is 2.508. So it is 2.508. It is negative 2.508 because it is a left-tailed test. If it is a left-tailed test, the critical t-value will be negative. So for the first subdivision, critical t-value equal to negative 2.508. So this is negative 2.508 for alpha equal to 0.01 and degrees of freedom equal to 22 when it is a left-tailed test. Then the next subdivision is the critical t-value for alpha equal to 0.1 with degrees of freedom 18 for a two-tailed test. So we have alpha equal to 0.1 and degrees of freedom 18. So the value is 1.734. So if it is a two-tailed test, then we have the critical t-value on the left side as well as on the right side. So the critical t-value will be negative 1.734 and positive 1.734. For the second subdivision, critical t-value is equal to negative 1.734 and positive 1.734. So here we have negative 1.734 and here we have positive 1.734. For alpha equal to 0.1, the meaning is that here we have 0.05 part of the area and here we have 0.05 part of the area, since it is a two-tailed t-test. Moving on to the next question. Suppose that 95% confidence interval states that population mean is greater than 100 and less than 300. How would you interpret this statement? So we have studied about confidence intervals. Confidence interval is nothing but it shows how much the researcher is confident whether a population mean is given within a given range. So here this 95% confidence interval is nothing but the population mean mu, it lies in the interval 100, this 300. We are 95% confident that the population mean is between 100 and 300. So this is how we can interpret this statement. Moving on to the next question. A shoemaker company produces a specific model of shoes having 15 months average lifetime. One of the employees in the R&D division claims to have developed a product that lasts longer. This latest product was worn by 30 people and lasted on average for 17 months. The variability of the original shoe is estimated based on the standard deviation of the new group, which is 5.5 months. Is the designer's claim of a better shoe supported by the findings of the trial? Make your decision using two-tailed testing using a level of significance of p less than 0.05. The meaning is that alpha is 0.05. So here we can see that there is a shoemaker company which produces a specific model of shoes whose average lifetime is 15 months. One of the employees in the R&D division, he claims to have developed a better product. This was tested on these 30 people and the average was found to be 17 months and the standard deviation was found to be 5.5 months. Now we need to test whether the designer's claim of a better shoe is supported by the findings of the trial. We have to use level of significance as 0.05. So with all these, first let us write the null and alternate hypothesis. So here this 15 months, this is the population mean mu naught. And here when the shoe that has been developed by this employee, when it was worn by these 30 people, the average was found to be 17 months. So this is the sample mean x bar and it has a standard deviation of 5.5 months. So this is the sample standard deviation, which is yes. So first let us write what all is given in the question. Mu naught is 15 months, n is 30, sample size is 30, and then sample mean x bar is 17. Sample standard deviation yes is 5.5 months. Now let us write the null and the alternate hypothesis. Define null hypothesis H naught and alternate hypothesis H1 as follows. H naught is mu equal to 15 months. Alternate hypothesis H1 is mu not equal to 15 months. Here we are asked to make a decision using two-tailed test. So we are given directly in the question. So we have the alternate hypothesis of this form. Thus a two-tailed test is applied under H naught. We have t equal to x bar minus mu naught upon s by root of n minus 1, or it is x bar minus mu naught upon s into root of n minus 1. Here x bar is 17, mu naught is 15, so it is 17 minus 15 upon s is 5.5 into root of n minus 1 is 30 minus 1, which is 29. So this is 2 by 5.5 into root 29. Now square root of 29, when we calculate, we get it as 5.38. So this when we simplify, we get it as 1.95. So we get the calculated value of t as 1.95. Now we have to find the critical value of t for alpha equal to 5% and degrees of freedom is, it is n minus 1, which is 30 minus 1, 29. So here degrees of freedom is 30 minus 1, which is 29. So here we have the t distribution table for alpha equal to 0.05 and degrees of freedom equal to 29. The area in one tail it is 2.045. So t 0.025 for 29 degrees of freedom it is 2.045. Now let us compare this critical value with the calculated value of t and check whether we can accept or reject the null hypothesis. So we got t 0.025 for 29 degrees of freedom as 2.045. So here it is a two-tailed test. So we have the region of rejection on both sides. Here we have negative 2.045 and here we have positive 2.045. If we see this value 1.95, it lies in this interval. So it is in the region of acceptance. The meaning is that we can accept H0. Since t equal to 1.95 lies in the interval negative t 0.025 to t 0.025 for 30 minus 1 equal to 29 degrees of freedom, we accept H0. So since we accept H0, it means that we have sufficient evidence to claim that mu equal to 15 months, or we cannot accept the designer's claim of a better shoe. The designer's claim of a better shoe, it is not supported. There is no significant difference between the product which is developed by the employee and the product which the company is already producing. Hence, we conclude that there is no significant difference between the average life of shoes of the two models, and the designer's claim of a better shoe is not supported. Moving on to the next question. An electric light bulbs manufacturer claims that the average life of their bulb is 2000 hours. A random sample of, I think some data is missing here. The sample size is missing. I think it should be 64. A random sample of 64 bulbs is tested and the life in hours recorded. The following were the outcomes. So, a random sample of these many bulbs were tested and the sum of their life, it is given summation x, it is 1,27,808 and summation x bar minus x the whole square, it is 9,694.6. Now we need to test whether there is sufficient evidence at 1% level that the manufacturer is overestimating the lifespan of the light bulbs. Actually, as far as t-test is concerned, we have this t-test for small samples only, that is for a sample size of less than 30. Here we are having a large sample size, so we are supposed to use a large sample test, but since the population standard deviation is not known, we can also use t-test. We have already studied that if the degrees of freedom is large, then the t-distribution tends to become a normal distribution. So the values which we see from the t-distribution table will be close to the values from the normal distribution table. That is the only difference. So here we have an electric light bulbs manufacturer who claims that the average life of their bulbs is 2000 hours. So this is the population mean mu naught. A random sample of 64 bulbs is tested and the life in hours is, it is recorded. The life is taken as x, summation x is given and summation x bar minus x the whole square is given. We have to test whether the manufacturer is overestimating the lifespan of light bulbs. So here we have to test whether there is overestimation in the lifespan of light bulbs. The meaning is that this is a one-tailed test. It is not a two-tailed test. It is a one-tailed test. So here we have n as 64 and the population mean mu naught, it is given as 2000 hours. We know only this much. Apart from the summation x and summation x bar minus x the whole square, the values are given. Now let us write the null hypothesis and the alternate hypothesis. The null hypothesis H naught, since it is a one-tailed test, we have H naught as mu greater than or equal to 2000 hours. And alternate hypothesis H1 as mu less than 2000 hours, assuming that the manufacturer is overestimating the lifespan of the light bulbs. So here this is a one-tailed test. Thus a one-tailed test is applied. We have T equal to x bar minus mu naught upon s by root of n minus 1, or it is x bar minus mu naught upon s into root of n minus 1. And now let us find x bar and s. The sample mean, it is given by summation x upon n. Summation x is given here. It is 1,27,808 upon n is 64. Now this when we divide, we get it as 1997. Now let us find the sample variance. Now variance formula you have studied in your class 11. If we take the variance as s square, it is given by 1 by n into summation xi minus x bar the whole square. If we have summation xi minus x bar the whole square or summation x bar minus xi the whole square, we are going to get the same answer, because if we interchange these two terms, we have the negative 1 whole square, it will become positive. So in place of summation xi minus x bar the whole square, we can use the value for summation x bar minus x the whole square, which is 9694.6. S square is 1 by n summation xi minus x bar the whole square. Now this value, it is given as 9694.6, or this when we divide, we get it as 151.48. So the sample standard deviation will be root of this, root of 151.48, it is 12.3. And now let us find T. Let us substitute all these values x bar, s, mu naught and n, and we can find the value of the test statistic T. Here T is x bar is 1997 minus mu naught is 2000 upon s is 12.3 into root of, here we have n minus 1. So 64 minus 1, 63. So this is negative 3 upon 12.3 into root 63 is 7.9. So this when we simplify, we get the value of T as negative 1.93. So if here we have a one-tailed test, so the value of T is 0.01 for 63 degrees of freedom. It is negative 2.39. Since it is a left-tailed test, we have the area of rejection only on one side, the critical T value. Now this area corresponds to 0.01 and the critical T value is negative 2.39. The calculated value of T is negative this 1.93. It is somewhere here. So it falls in the region of acceptance. As a result, we accept H naught. So if we accept H naught, we have sufficient evidence that the manufacturer is not overestimating the lifespan of the light bulbs. So the lifespan of the light bulbs, it may be same as 200 hours. Since t equal to negative 1.93 is more than t 0.01, that is negative 2.39. We accept H0. So if we accept H0, we can conclude that the manufacturer is not overestimating the lifespan of the light bulbs. So this is the conclusion. Moving on to the next question. A fertilizer company packs the bags labeled 50 kg and claims that the mean mass of bags is 50 kg with a standard deviation of 1 kg. An inspector points out doubt on its weight and tests 60 bags. As a result, he finds that mean mass is 49.6 kg. Is the inspector right in his suspicions? So here we can see that a fertilizer company, it packs bags labeled 50 kg and claims that the mean mass of the bags is 50 kg and the standard deviation is 1 kg. So here this is the population mean mu naught, this is mu naught, and this is the population standard deviation sigma, the standard deviation sigma. An inspector points out doubt on its weight and he tests 60 bags. He finds that the mean mass is 49.6 kg. So this is the sample mean. This is the sample mean x bar and this is the sample size n. We have to test whether the inspector is right in his suspicions. Since here we have the population standard deviation which is given and the sample size is also more. Again here we have large sample test. As I already mentioned, as the degrees of freedom increases, t distribution tends to become normal distribution. So we can also use t test for this. So first let us write what is given. Mu naught is 50 kg, sigma is 1 kg, sample size n is 60 and sample mean is 49.6 kg. First let us define the null hypothesis H0 and the alternate hypothesis H1 as follows. So H0 is mu equal to 50 kg and alternate hypothesis H1 is mu not equal to 50 kg. Thus a two-tailed test is applied under H0. We have t equal to x bar minus mu naught upon, if we see before studying about the formula for the test statistic t, we had t is equal to sample mean minus population mean upon standard error. This standard error is nothing but it is sigma by root n. So it is x bar minus mu naught upon sigma by root n. Here since we have sigma, so we can use this formula itself directly instead of having an estimate for the standard deviation. And also here the sample standard deviation is also not given. So here we can use x bar minus mu naught upon sigma by root n. Let us substitute all these values. So x bar is 49.6, mu naught is 50 upon sigma is 1 by root of n is 60, or it is negative 0.4 into root 60 is 7.74. So this when we simplify, we get it as negative 3.098. Now we need to find the critical value of t at 5% level of significance and 59 degrees of freedom. If you see the t distribution table, we can use the degrees of freedom which is close to 59, that is 60. Since here the level of significance is not given, we can assume alpha as 5%, assuming alpha equal to 5%, T 0.05 for 60 degrees of freedom. It is equal to 2.0. So it is a two-tailed test. Here we have -2 and +2 here. The calculated value of T, it is -3.098. It lies in the region of rejection. So we reject H0. It means the inspector is right in his suspicions. Since T equal to -3.098 does not lie in the interval, T 0.025 for 60 negative T 0.025 to T 0.025, that is -2 to +2, we reject H0. If we reject H0, it means that the mean weight is not equal to 50 kg. The inspector was having a doubt on its weight, and that is why the inspector has tested 60 bags. Now the inspector has claimed that it is not equal to 50 kg. So the inspector is right in his suspicions. Hence we conclude that there is significant difference between the mean mass and 50 kg, and the inspector is right in his suspicions.